Hi everyone, so let's discuss vectors. So in physics, we will encounter a lot of vectors. So I want you guys to understand what vectors are, how to visualize vectors, and how to solve problems using vectors. Okay, let's begin with what are vectors. So vectors are represented by an arrow or a directed line segment. We usually utilize uh, call this a boldface uh, font for vectors or an arrowhead above. Okay, so vectors are a characterization of both direction and magnitude. And you could actually also solve for the magnitude of the vectors. And this is notated as the norm, no, or the length. No? This double vertical bars here, so you can see this means that this is the length of the vector in this form or in this form. Okay, so given vector v, let's just imagine this vector v here. As you can see, we have A as our initial point, which is also called the tail. And then the B here is the terminal point, the end point, which is also called the tip, which is B. So basically, it's just the vector. Now we have initial point and the terminal point. We have this length. We have this direction. Now, assuming that, let's say, this U and V vectors have the same length and pointing at the same direction, then they are considered equivalent. Okay? And another thing about vectors is sometimes vectors doesn't have a length. So we call them a zero vector. Okay, so let's differentiate vector quantity from a scalar quantity. So a scalar quantity has magnitude only and has no direction in space. But vector quantity has both magnitude and direction in space. Okay, so an example of a scalar quantity are the following. So we have the length, area, the volume, time, mass, so on. So anything that has a magnitude without the context of direction. Okay, and then the vector quantity are the following. So the displacement, the velocity, the acceleration, the force. So every one of these examples has a magnitude and a direction. So velocity has a magnitude, its speed and its direction, usually in terms of an angle or utilizing a unit vector. All right, so let's talk about the component of a vector. So given you have a vector A, as you can see here, let's say this vector A, you can break this down into its components, A sub x vector and the A sub y vector. As you can see here, it is both in boldface and with an arrowhead, notating that it is a vector. Although sometimes I'll just write an arrowhead or in boldface if it is typewritten. So to solve for its components, this is similar to what we did in the coordinate system. So this is just another notation, but everything is similar. So let's talk about only the length for now, no? At least for the first concepts. No? So the length of A, or the magnitude of A, is notated as, again, so A vector is equal to the magnitude or the length. So relating this length to each other, as you can see, this is just our Pythagorean or right triangle. You can utilize the Pythagorean theorem or the sine and the cosine. So for A sub x, that is just A cos theta. Sorry. And then for A sub y, we have A sine theta. And then for A, the relationship of A and x and y, we have the Pythagorean theorem. And to solve for the angle, we have tangent theta. Okay? Assuming that this vector lies, or the terminal point lies on the quadrant 1, and the initial point is at the origin. Okay, let's have an example. The resultant of two forces at right angles is 100 newtons. If one of the forces makes an angle of 30 degrees with the resultant, compute the force. So the resultant of two forces at right angles is 100 newtons. So let's visualize the problem. So let's say this is your resultant. Two forces at right angles, meaning this is the component 1 and this is the component 2. So this is the component in x. So let's just call this a sub x. And this is a sub y. And this is your a. So what we want to solve here is the... Okay, so if we want to force create an angle of 30 degrees, from here 30 degrees, we want to solve for the forces involved, or at least the force that makes the angle of 30 degrees. So we're trying to find for AX. So we have a given of A that is 100 Newton. We want to find what is AX. So therefore we could utilize the formula earlier. So recognizing that A sub X is a magnitude, guys, no? Or a leg, this is equal to A cosine theta. Okay, so where did this came from? From the formula last time. Or you can create this formula using the Pythagorean, or sorry, the trigonometric identity. So A sub X is equal to 100 Newton cosine 30 degrees. So AX is equal to, let's use a calculator, 100 cosine 30. So this is 86.60. So 86.60 newtons. Okay. So that's all. No? That is the easiest way to visualize this problem and solve this. Okay, let's move on to the next one. So let's talk about vector addition. So what we did with regards to the vector components, if we add these two vectors, a sub x and this a sub y, the resulting vector will become a. So to visualize this vector addition, given vector u and vector v, if we add these two, we could just connect these vectors. It will form this line at which the terminal point will be the end point here, and the initial point will be the initial point. So the length of this vector will be the length of this the sum of these two vectors, and this is called the triangle law. Okay, and consecutively, you can actually swap this. Instead of having u as the first vector, we could make v as the first vector and then connect the two. Okay, if you connect the two vectors, the resulting sum will be the same, and this is called the parallelogram law. Okay, so again, let's summarize what I just said. So let's say we have a given vector a and b. If we add this vector a and b, we could have this a and b connected to each other. So let's say this a, this is b. We start with the initial point of a to the terminal point of a, and then at the terminal point of a, we have to connect the initial point of b. So we will write something like this to get this to get the resultant vector which will be this. So this will be a plus b. Alright? So using the triangle law, this will be your resulting vector, or using the parallelogram law, you could also do this cumulatively. You do the b first after, and then do the a. You will arrive at the same solution. Okay, so this can be done not solely for two vectors. This could be utilized for two or more vectors. So let's say you have a given vector a and vector b. The sum of these two vectors will be, let's say, the resultant or vector, which is visualized as this. But it could be more than two. It could be four vectors or more. So the resulting vector is that when we connect these vectors one by one. Okay, so that's basically how we add vectors visually. So we could we could find the resultant vector graphically even without computation, as long as we are accurate in disposing the length here and the directions. If you're consistent with the precision of your angles and your distances, you can just measure the length of this and the angle here to find the resultant vector. And that is what we will do later for an example. Alright, so vector addition, it could be graphical, it could be algebraic method. So let's talk about the graphical method first and then the algebraic. So for the algebraic, we will basically just add the vectors. No? I will just do this by example, but take note of the following. So this is similar to what we did last time. The resultant vectors and then the angles. So take note of the angles, what we did last time, that the angles or sorry, the signs of the coordinates will be dependent on at which quadrant it lies. So, okay, let's have an example here that is pre-made. No? I pre-made this problem, and basically a hiker begins a trip by walking 25 kilometers, 45 degrees south of east. So this is the starting point. Okay. This is the starting point, and then this hiker travels southeast, or where is it? South of east. So south of east, meaning the south of east. So if this is east, then the south of east will be this angle 45 degrees. And then after a while, or at the second day, she walks 40 kilometers in the direction 60 degrees north of east. So the north of east, so if this is east, the north of east is 60 degrees. So we have to pinpoint here 60 degrees. And then after a while, the hiker reaches this point. So how do we find the resultant vector? So if we add this, actually what we did here is vector addition already. So this is the first vector, and this is the second vector. So therefore, the resultant vector will be this vector. Okay? And how do we figure that out? So assuming that your scaling here will be 5 kilometers to is equal to 1 centimeters, we could just use a ruler. No? So finding out the rulers, assuming that you have drawn this already, you could solve for the resultant vector, which will be 8.2, as you can see here. This will be approximately 8.2. So if this is 8.2 centimeters, and we want to convert this into kilometers, if the ratio of scaling is this, so we have 8.2 cm multiplied by 5 kilometers over 1 centimeters. Therefore, this is equal to, we have 8.2 times 5. And so approximately 41 kilometers. Okay. And then, to find for the angle, you could also find angle here. So, let's try moving the protractor, guys. Let's try moving the protractor. No? So, the protractor, just move the protractor here. So, approximately the angle of this, resultant vector, is that fine? I think this is approximately 24 or 25 something. So we're getting here a theta of about 24, right? That is 24 or 25 degrees, somewhere in between. Let's just call this 25 degrees. So graphically, we have a solution. Now, but how do we do this analytically? Let's try to do this analytically. So let's solve this one by one. So we have here again, drawing of the hiker. So we have here 45 degrees. And then after that, 60 degrees. Okay. So, what we could do here is to add these vectors. So adding these vectors, knowing that we have, what do you call this? 25 kilometers and 45 degrees. So the given here is 25 kilometers and 45 degrees. And then the other one was 60 degrees and 40 kilometers. Yes, 60 degrees and 40 kilometers. Okay, we could just create a vector reflecting this one, and then we just add the vectors, and that will be over. So how do we do that? So we can tabulate our solution. So we have the first vector, so vectors, let it in the vector, and then we tabulate the x component here and the y component. Okay, so for vector 1, let's just call this vector 1. No? Vector 1. Okay, I think this, but it's much more fitting to use vector A. So vector A has a component of what? So since this is on the quadrant 4, okay, quadrant 4, so positive yung x natin, no? So positive x, negative y, right? Since positive towards the right, negative downwards. So the x component will be, again, x component, that is equal to r cosine theta. So we have a given here 45 degrees. Therefore, this will be, so r is 25 cosine 45. Okay, so we just write this down here, and then the y component is equal to r sine theta, that is equal to 25 sine 45. Okay, so this will be the same, guys, no? So 25 cosine 45 in degrees. We have 17.68, and that will be the same for cosine and sine, since this will be an equilateral triangle. So 17.68. Okay, but take note of the signs. Again, positive x, negative y. So this should be negative, the y component. For vector B, we have here, we have 40 kilometers and 60 degrees. So visualizing this again, so we have here 60 degrees. And since this lies on the quadrant 1, so towards the right, positive, yung x, and then upwards, we have y. So both x and y are positive. So we can just solve this x component, that is r cosine theta, that is equal to 40 cosine 60. Okay, and then y component is equal to r sine theta, which is equal to 40 sine 30. So this will be equal to 40 cosine 60. That is 20. So this will be 20. Okay, and then let's just swap this one sine. So 20 square root of 3, or 34.64. 34.64. Okay, so what should we do here? We can just add this component. So guys, no, we can just add these components to find the x component of the resultant vector r. So adding this to, we have 37.68 for the x component, and in here, guys, the calculator, 34.64 plus negative 17.68, we have 16.96. Okay, so what does this mean? Basically, this is your component for r sub x, and this is your component r sub y. So therefore, to find for the resultant vector, or the length of the resultant vector, that is equal to rx squared plus ry squared, and the square root of that. So r is equal to square root of 37.68 squared plus 16.96 squared. Okay, so computing this, we have 37.6. So we have 41.32. 41.32 kilometer. So you can see, this is almost equal to what we did graphically. No? Okay, so this will be the analytical solution. And then after that, we could also solve for the, sorry, for the theta. Since the resultant vector, looking at this, we have the resulting vector in this direction. So we could just solve for this theta. So we could just do this directly. And your Ry will be this, and your Rx will be just this. So we can do this directly. The theta will be equal to arctangent 16.96 over 37.60. So theta is equal to okay, tama. Sorry. So arctangent 16.96 over 37, sorry, over 37.60. So 24.23. Okay, so as you can see here, similar, almost similar to what we just measured. So this one. Okay, so that will be how do you solve problems using vectors on the context of vector addition. Okay, so let's try this again. We have another scenario here. Instead of just two vectors, we could add more than two. Okay, so let's tabulate what we could compute here. So let's start with the first vector here, the first vector 1. So what is the x component of this vector? So since this is only in the x-axis, this will be 100. Okay, 100 meter. And then for the y component, since this doesn't have a transversing distance, it is only a horizontal line, no y component, the y component will be 0. Okay, be mindful now, since this is towards the right, this is positive. Okay, be mindful of that. And then for the second vector, this one, 300, the x component here will be 0, since this is only upwards or downwards, right? So downwards, it has no x component. But the y component will be 300 meters. And if this is going downwards, this should be negative. So take note that this is negative 300 meters. Okay? And then for the other one, for the next vector here, so this vector has both x and y components. Okay? So since this one is heading to the left, its x component is negative, and going downwards, the y component should be also negative. So how do we compute this? So we have here a triangle, 30 degrees. We have a given 150. We want to solve for its y component and its x component. So using the trigonometric identities, we solve for x and y. So for the x component, we will use cosine. So cosine 30 degrees, and then the radius, which is 150. Take note of the sign, guys. So this is negative since this is heading to the left. And then another one here, which is also negative, which is 150 sine 30 degrees. Okay, sine for y components. So let's evaluate this first using our calculators. 150 cosine 30. So that will be 129.9. So 129.9 meters. Or sorry, negative. No? It should be negative, but I won't. I already shown that this is negative. And then we have here 150 sine 30. So 75. So 75 meters, that is negative. And then for the last one, okay, so the end here has a negative x, so towards the left. Its x component is towards the left, and then upwards, positive y. Okay, so using this triangle, we have a radius of 200 meters, angle of 60, and then x and y. So for, again, the x component, we have cosine 60 degrees, and the radius 200. And then the sign, again, the sign should be negative since it is towards the left. Okay, and then for the y component, since this is positive, I won't write this down anymore. Or should I? Okay, 200 and then sine 60 degrees. And then evaluate this using our calculators. 200 cosine 60. So 100. And then sine. So 100 and 173.2 meters. So what should we do here to get the resultant displacement? We will just add everything. So for the x component, we will just everything here. Okay, so we have 100 and then minus 129, since this is negative, 129.9 minus 100. So the resultant vector is negative 129.9 meters. And then for the resultant vector of y component, we have negative 300. And then we have negative 150. And then positive, sorry, not 150, sorry. Minus 75 plus 173.2. 173.2. So the answer should be negative 201.8 meters. So what is the resultant displacement? Later on, we will discuss about the unit vectors. But for now, let's just find the magnitude. So the magnitude R will be equal to the square root of Rx squared plus Ry squared. So this will be equal to square root of 129.9 squared. Okay, we could just neglect the negative sign here for now, if you want. Okay, since it will just cancel out. Anyways, I will just write this down in the solution. So R here will be equal to square root of 129.9 squared plus 201.8. Oh, sorry. Okay, going back. Square root of 129 squared plus 201.8 squared. Alright, so we have 239.99, basically 240. So our resultant vector is 240.0 meters. Okay, that is just the magnitude. How do we find the angle? So to find the angle, as we can see here in the image, assuming that this is by scale, no? So it is probably by scale. So we want to find this theta. So we could find this alpha here, guys, to find this theta. So again, I will write this down. So therefore, your resultant R vector will have an alpha here and then another one, which is theta. So therefore, theta is equal to 180 degrees because this is 180 plus alpha. So to get theta, we have here 180 degrees plus. So how do we find alpha? We have here, so this is alpha. We have the coordinates here for x and y. So this is negative 129.9 and this is 201.8. Although we assume that this is positive, so let's make this positive so that this angle will always be positive. So we have arctangent 129.9 over 201.8 over 129.9. So the angle theta, will be equal to, so arctangent 218, so 237.23 or 237.2 degrees. Alright. Okay, so let's try another one, even last one. No? We have another problem here. Okay, sige. Let's do this faster since we are already familiar with the concepts. So we have 5 coplanar forces. So let's start with the first one. Let's start here, no? And then make our way counterclockwise. So we have 19 as our magnitude. So the x component is 19 since it's positive. And then y component is 0. And then for this one, we have 15 cosine 60 degrees. So both of them are positive, no x and y coordinates. And then 15 sine 60. Let's evaluate this later. And then for the third one, we have 16. So in here, we have a negative x, since this is towards the left, and a positive y. So this is negative, this is positive. We have 16 cosine 45. Okay, and then we have 16 sine 45. And then the next one, we have here 11. So both of the x and y here, so left is negative, down is negative. So both x and y will be negative in sign. So we have here 11 cosine 30 and 11 sine 30. Okay, the last one, we have 12. So since this is only downwards, we do not have an x component, and since this is downwards, we have a negative y component, which is 12. So let's solve for the following. Actually, we do not need to solve this anyways. No? We could do this directly here. Let's solve for this directly. We calculate this at home. Depends on you. So let's calculate this directly so we can do this faster. So we have 19 plus 15 cosine 60 minus 16 cosine 45 minus 11 cosine 30. So we have 5.66 here, 5.66. So this is positive, okay? And then for the other one, we have 0 plus 15, 15 sine 60 plus 16 plus 16 sine 45. Sorry, I cannot do it. Plus 11 sine 30. Plus, or sorry, minus 12. I forgot the sign, sorry. So the sign for 11 sine 30 should be negative. Alright. So the answer should be 6.804. 6.804. Let me check the significant figures for the last one. Okay. We did okay. So if both of this components are positive, if they are both positive, guys, that basically means that they are in quadrant 1. So if x is positive and y is positive, it lies on the quadrant 1. So we can just find the theta directly, which is angle or arctangent. We have 6.804 over 5.66. Okay, let's solve for theta. So theta, that is equal to shift arctangent, so 6.084 and then 5.66. Okay, so we have 50.24. Okay, and then for the resultant vector, or the magnitude of this resultant vector, that is equal to the square root of this and this. So I will do this directly, guys. We have here the square root of 5.66 squared plus 6.804 squared. Okay, so we have a resultant vector that has the magnitude of 8.85. What is the unit? In newtons. So this will be your magnitude, and this will be your direction in degrees. Okay, so let's discuss, I guess let's briefly discuss these unit vectors. I don't think so. I think that will be the end, no? So let's discuss this further next time. Okay, thank you guys.